These are the frequently asked questions for pre-calculus for section 7-1, day 2. Got some nice word problems here to work through. 46 is personal income. It says table 7.3 gives the total personal income in billions of dollars for residents of the states of Iowa and Nevada for several years. Let x equals 0 stand for 2000, x equals 1 stand for 2001, and so forth. So right away, before punching anything into my calculator, I would make that change. We want all this information since the year 2000. A says find the linear regression equation for the Iowa data and superimpose its graph on a scatter plot of the Iowa data. B says we're going to find the linear regression equation for the Nevada data and superimpose its graph on a scatter plot of the Nevada data. And then for C, remember I had said we're going to change this up and we're going to say when will Nevada's personal income be the same as Iowa's. So that's the change that we have. Now, we just need to get this data in. So under stats and edit, you would go ahead and put all of that information in. So your X's are going to be your years, 2, 6, and 7, 8. And then list 2 will be Iowa in billions of dollars, and list 3 will be Nevada in billions of dollars. And then we need to do our linear regression. So we're going to do stats, calculate, and our linear regression number 4. And since this is a newer calculator version here for software, I have list 1 and list 2 up there, which means this will be for Iowa. And what I want to do is go ahead and go to store frequency, and I'm going to store regression equation. I'm going to store this as y1, so it'll be all ready to graph. So variables, y variables, number 1 for functions, number 1. And when I hit enter, it'll calculate that. So there's the first part of our answer. That is the linear regression model that we need for A. Oops, that's a little unreadable there. Try looking at what I write. Y equals 4.495x, and that'll be plus 72.628. And again, we have to write it down because that's part of the problem, but this is already stored in y sub 1 thanks to the way that we punch it into the calculator. So decimals and all of it is perfect. And then stats, calculate, and we do want linear regression again. But now what we have to do is make sure that this uses list 1 and list 3. So we're going to hit second 3, and that's going to change that to list 3. And I also want to store this as y sub 2, so variables, y variables for functions, number 2. And down to calculate. And there is part B, y equals 6.634x plus 54.306. Now it did say to, superimpose these on top of the scatter plot. So let's go ahead and go in and take a peek at that. That's going to be second y equals. And for number 1, I want to turn this on. And this is already going to use list 1 and list 2, which is good news. And then I want to go back and also turn on a second plot. But I need this one to use list 1 and list 3. Now mine's already set, but again, you could hit second, number 3, and that'll put list 3 in there. And because this is going to be the color version, we'll be able to see those. But what we have to do is mess with the window here. Our x values were 2 to 8, so maybe 0 to 10 cover what we need. And then we take a look at our y values, and we realize we're really starting there at about 66.6 at the low end, and going up to 110 or so. So maybe I'll go from 50 to 150. And graph. So this has the scatter plot and because we have y sub 1 and y sub 2 already stored in there. They are also going to see those lines for the linear regression. And there they are. And even better yet, now this is ready for part C, which is when are they going to be equal. So second trace, number 5, and enter 3 times. And there it is, 8.567. So I think, well, when is that going to be? Well, 8.567 means it's going to happen 2000 plus 8.567 years from now. So sometime during 2008, they will be equal. And if we wanted to, we certainly could put what that billions would be at that point, that 111.139. And then, since this was income, we want to put some dollars on there. So, like I mentioned, we changed C to say, when will they equal each other? For A and B, you're superimposing those graphs. If you just want to make me a little sketch for A and B of what you saw, that would definitely do it. So, you take a look at what you have going on here, just make a few dots for what we're plotting there, and then show the lines intersecting. So, that one, quite a bit of calculator work for that. I'm going to stop this so that I can get the calculator turned off. The next 2 problems, I was kind of surprised to see up here. You must have been making a little math mistake or something on this, because this is much like the examples we were doing in class. So we've got a rectangle. We don't know the dimensions, but we know about rectangles. So we use that to our advantage. And it has a perimeter of 200, so 2x plus 2y equals 200, because perimeter means if you added up all the sides, what would you get? And then we have an area of 500, so x times y equals 500. So it's up to you whether or not you want to get the x or the y. We definitely would use substitution for this one. And for number 49, let's see, which way did I go here? It makes absolutely no difference. I guess I got x alone. So 2x plus 2y equals 200. And we would subtract the 2y on both sides. So x equals 100 minus y. Now, we want to take this and put it right here. So this will become 100 minus y times y equals 500. So next up, we would distribute, and then we'd move everything over to one side. And as I talked about in class, I will usually move things over so that my first term is positive, that coefficient of the y squared term is positive. Looks like so. 2 numbers that multiply to 500 and add to 100, or you could use the discriminant here and you'll see that that's not going to be factorable. So let's move that 500 out of the way and complete the square. And I guess if somebody were going to make a mistake, this might be it right here. You know, you want to think about the fact that you need 100 divided by 2, which is going to be negative 50 squared. So that's going to be plus 2,500. And that will give you 2,000 equals y minus 50 squared. So I guess I think common error, somebody might accidentally put a 10 here, you know, because we do have a perfect square for that y. But remember, that is b over 2 that goes in that position. And, oops, we got a 0. Now we would square root both sides. And then we would add 50. And we check out what we get. So if we take 50 plus the square root of 2,000, that will give us one of our answers there, and that will be 94.721 meters for y. And then if we just plug that back in, we absolutely have a beautiful little formula here for that. In fact, if we already have this in there for our answer, all we have to do is 100 minus answer to get x. So take 100 minus the 94.721 blah, blah, blah answer that you have, and that will come out to 5.279 meters for x. And remember, these are interchangeable. You know, we could have x equals 94.721 meters, and we could have y equal 5.279 meters. It doesn't make any difference. So what we want to do at the end is just give the dimensions. So the dimensions would be 5.279 meters by 94.721 meters. And I say by because the x always kind of drives me nuts there. You know, we are dealing with algebra here, so I would prefer to go ahead and actually write that word in there. Those are the dimensions for number 49. Number 50, we have a similar problem. Rectangular cornfield, perimeter of 220, we don't know either dimension. So 2x plus 2y equals 220 yards, and x times y equals 3,000. That's how a rectangle is. And then again, what we would do is use substitution here. I think I'll get x all by itself. So taking the first equation, recognizing everything here is divisible by 2. So this would be an easy way to work through this. So x equals 110 minus y. That needs to go here. And away we go. We would distribute. Move everything over. And we could certainly take a little time, check the discriminant, but we're going to find out there that 3,000 is not going to work for us. This is not a perfect square trinomial. So we would subtract 3,000 from both sides and complete the square. We need negative 110 divided by 2 squared, which is going to be negative 55 squared. And that is 3,025. So on this side, we now have a nice little 25. And over here, we have y minus, remember, b over 2. That would be 55 squared. And then what we have to do is take the square root of both sides. So we will get plus or minus 5 equals y minus 55. And then we would add 55 to both sides. So 55 plus 5 would be 60. 55 minus 5 would be 50. And again, it doesn't matter which one is x and which one is y. These are going to be the two answers. And here's why. If we go back up looking for that nice little shortcut that we had up here, x equals 110 minus y. And 110 minus 60 is 50. 110 minus 50 is going to give you 60. So forwards and backwards, this is definitely going to work. So this would be yards. And again, it doesn't matter which one's x, which one's y. There it is. Number 52, yeah, this is an interesting problem. What we have to remember is the distance equals rate times. Make a little sketch here, and hopefully that'll help us out. So we've got an airplane flying with the wind. So the wind is helping to push it along. And we could make that x, y, it doesn't matter. But what we need to pay attention to is the fact that the wind is pushing them forward. And when that happens, their trip takes 3.75 hours. But against the wind, which would be a subtraction of the wind, you know, using distance equals rate times time. That one takes them 4.4 hours for the return trip. And it says if the air distance between Los Angeles and New York is 2,500 miles and the airplane speed and wind speed are constant, find the airplane speed and the wind speed. So what we have to do is figure out that both of these are talking about distance. So both of them are going to equal 2,500. But with one, with the 3.75, they have the wind helping them out. So the rate is something plus an additional little push from the wind. And this is setting it up as distance equals rate times time. But the other one is 4.4 times x minus y, because they're fighting against the wind. So we have the time over there, and the rate is being pushed along by the wind or fighting the wind, going the other way. So what we would want to do is go ahead and distribute this and see what we have. So we have 2,500 equals 3.75x plus 3.75y. And then we have 2,500 equals 4.4x minus 4.4y. And at first you might say, well, they both equal 2,500. Let's just set them equal to each other. Well, we could do that, but we still have two unknowns, and we still need a second equation. So what I did was I decided I'm going to go after x in the bottom equation, and that's because the decimals don't work out quite as bad with the bottom equation. And we can add 4.4y instead of doing subtraction. And it ends up not too bad. So we have y plus, well, it's 2,500 over 4.4. Right now I'm going to leave it as 568.182, but I certainly could punch in 2,500 divided by 4.4 whenever I need an exact answer for this. So this equals x, and I have not used the top equation yet. So 2,500 equals 3.75 times y plus 568.182 plus 3.75y. So 2,500 equals 3.75y plus, and yeah, you know, we'll do a little bit of rounding here to the 3 decimal places, but it is still in the calculator. So you can just take the answer that's in the calculator times the 3.75. So 2130.682 plus 3.75y. So 2,500 equals, well, that would be 7.5y plus 2130.682. And we would subtract that obnoxious answer from both sides. And that will give us, oh, let's see. Well, let's just go ahead, once we have that answer, let's just go ahead and divide that. But this will be 369.318 approximately, and divide by the 7.5. And y comes out to be about 49.242 miles per hour. And then it's go back and figure out what we're going to have for x. And this is definitely what we would want to use right here. So we would take our answer, the 49.242, and we would add 568.182. Or you could add, to keep this exact, you could add the 2,500 divided by 4.4, you know, put that in parentheses so that everything will work out perfect. And that would be 617.424 miles per hour. So pretty obviously this is your wind speed, and this is at your actual flying speed right here at 617.424 miles per hour. That's kind of a doozy with the wind pushing you and fighting you on the way back. 53 says, at Phillips Convenience Store, the total cost of 1 medium and 1 large soda is $1.74. The large soda costs 16 cents more than the medium soda. Find the cost of each soda. So 1 medium plus 1 large is $1.74. But the large soda is 16 cents more than the medium. So if you take the medium plus 16 cents, you'll get the large. And this is perfectly set up for substitution here. This can go right in for L. So M plus 16 cents equals $1.74. 2M plus 16 cents equals $1.74. So 2M will equal $1.58. And M will equal 79 cents. So this is the medium drink. And then all you'd have to do is add 16 cents to that to figure out what the large is going to cost. So 0.79 plus 0.16, and oops, that should be L, and that is 95 cents. For the large. 54. A 5-pound nut mixture is worth $2.80 per pound. The mixture contains peanuts worth $1.70 per pound and cashews worth $4.55 per pound. How many pounds of each type of nuts are in the mixture? I saw two labels here. There's one about pounds and there's one about money. I'm going to go after the money first. We've got peanuts at $1.70 a pound, so $1.70p plus $4.55c cashews equals. Now, you have to figure out how much would that 5-pound nut mixture cost. Well, it's 5 pounds at $2.80. So you need to multiply those together and figure out that this is going to be $14 for those nuts. And we don't know how many pounds of each, but we know that the peanuts plus cashews has to come out to 5 pounds. So the two labels here, pounds and money, really drive how you're going to set this up. And then at this point, you know, nice and easy substitution here. I would just subtract C from both sides and put this in for P. And do some solving. So this would give us 8.
Just a reminder, students, the link.
Perfect bad timing by the bell there. This will give us 8.5.
Jordan Wallace.
8.5 minus $1.70C plus $4.55C equals 14. So 8.5 plus 2.85C equals 14. And 2.85C equals 5.5 by subtracting that 8.5 from both sides, and then by dividing. There's our cashews. And we know that there are 5 pounds total, so this is pounds of cashews. And then if you take 5 minus the 1.930, you'll get pounds of peanuts. And that will give you the 5 pounds that they wanted.